All right, geometry, we are still going down the right angle path and perpendicular lines, just getting more and more detailed as we go. So first of all, let's do a little review. Carlos thinks that the segment having endpoints 0, 0, and 6, 0 is perpendicular to the segment with endpoints 0, 0, and negative 2, 0. Do you agree? Why or why not? So what we're going to check is point C against point B. 6 times negative 2 plus 0 times 0 is not equal to 0. So no, they're not perpendicular. Okay, that would be a true statement if they were perpendicular. So working with a partner, by your lonesome, given A is 0, 0, and B is 3, negative 2, find the coordinates of C so that AC is perpendicular to AB. So basically we need B times C, which we'll just say is XY, is going to be equal to, using that formula is going to be equal to 0, 0, right? Let's use CD. XY is a little misleading, not much, but whatever. So if we did this, that means that we have 3 times C plus negative 2 times D is equal to 0. What do you think? Okay, that means AC would be perpendicular to AB as long as we chose values for C and D that made that a true statement. So let's try to solve for it a little bit. Let's say that D equals 3/2 times C. So we need some values that would make this true. So let's just choose, I don't know, C equals 2. So if I plug a 2 in for C, D would be 3. So that's a possibility, right? How about C equals 4? So if I go D equals 3/2 times 4, 3 times 2 is 6. That's a possibility too. Do you get the idea? I could put in a 6 and say, all right, D equals 3/2 times 6. That gives me 3. 3 times 3 is 9. These are all possibilities. I could go on, but I have other things to do. So we're going to stop with 3, but it could be an infinite number of coordinates, right? Okay, let's try another example. So here we have points 2, 2, which is point A, point B, C, and D. Are A, B, and C, D perpendicular? Are the lines containing the segments perpendicular? So the segments A, B, and C, D, are they perpendicular? I'm not sure. Let's see if I do that. Let's see if we can get a little line here. Yeah, let's try again. Are those segments perpendicular? Are the lines containing the segments perpendicular? Well, I mean, what we learned in the last lesson is if I can translate those points to the origin, then my work becomes a lot easier. So if I can translate A, which is 2, 2, to the origin, so I'm going to get A prime, which is 2 minus 2, 2 minus 2. So A prime is 0, 0. That's what I was going for. So if I subtracted 2 from that, then I could do B, since it's a segment. That's 10, 16. So B prime would be 10 minus 2 and 16 minus 2. So there's my segment, right? Now let's do C. I'm going to put C at the origin. I could put D at the origin. It really doesn't matter, but I'm going to go for C. C is negative 3, 1. So C prime is going to be negative 3 plus 3 and 1 minus 1. That gets me 0, right? So C prime is 0, 0. So I have to translate D the same because they're a segment, they're attached. So 4 plus 3 is 7, and negative 3 minus 1 is negative 4. So there is D prime. So let's see if AB is perpendicular to CD. So these are the 2 points that I'm going to do my fun little math with. Let's do 8 times 7 plus 14 times negative 4. That gives me 56 minus 56 is in fact 0. So yes, the segments are perpendicular. Therefore, the lines that pass through the segments are also perpendicular. Cool? Cool. All right, a fun exercise. So this one is making us think outside the box just a little bit. We need to come up with another equation that's going to help us prove things are perpendicular. And we're doing this with all variables, which is a little bit of a pain, but it's okay. What I want to do, since I've got 4 points here, I want to find a general formula that helps us determine whether those two segments are perpendicular. So just like the last problem I just did, I'm going to take 2 of these points and get them to 0, right? So let's try that. I want to get A, which is A1, A2, to be A prime at 0, 0. So I just subtracted A1 and A2 from each coordinate. So I'm going to do that with B. B is B1, comma B2. So B prime is going to be B1 minus A1, comma B2 minus A2. Just like with the last example, here, let me do all the work, show all my steps. A1 minus A1 is 0, and A2 minus A2 is 0. So I get A prime as 0, comma 0. And B prime is that fun little guy. Cool? Awesome. So do the same thing. I'm going to move C to the origin. And D to the origin. Oops. D prime would be D1 minus C1, comma, D2 minus C2, because I'm subtracting that from both of the ordered pairs, so I can translate them both to the origin. So to find out if AB is perpendicular to CD, A and C are both at the origin. So I can take B and D and do my fun little math with it, right? So we can go, let's do this. B1A1 times D1C1. Oops, I did not mean to do that. Plus B2A2 times D2C2. And I'm out of room. I hate it when that happens. Yay, I did it. So that right there, if this in fact equals 0, then those two segments are perpendicular. So just like the last lesson, that's a lot of letters. I don't want to confuse you. This right here is what you need to know, right? Cool. All right, let's try one. It's given that AB is perpendicular to CD, and I've got lots of points there. Notice D, I don't have the Y value of the ordered pair. We need to find the value of D2. So we're going to use the formula that we just came up with in exercise 1, the last slide. So we're going to use that formula, and it's going to be helpful to go through each step. So first of all, I'm translating AB to A prime B prime so that A prime is at the origin. Okay, so I'm moving 3 units to the left and 2 units down. So minus 3, because the left is minus. Let's do that. So minus 3 and minus 2. Minus 3 and minus 2. Okay, so that gives me B prime as 7 minus 3 is 4, 10 minus 2 is 8. Okay, let's actually write it out though. 10 minus 3 and, nope, so sorry, 7 minus 3 and 10 minus 2. Now, we want to translate CD to C prime D prime. So C prime is at the origin. Notice I'm doing this without any pictures. That means here I'm going to add 2 and add 3. So my C prime is going to be negative 2. No, not my C prime. I got distracted. D prime. Add 2 and add 3. So D prime is going to be 4 plus 2 and D2 plus 3. I still don't know what D2 is, do I? But it's okay. We know that when I multiply these together, I'm going to get 0. So I've got an equation, right? All right, so let's do this. I've got these two multiplied together and these two multiplied together, and that's going to be equal to 0. So 7 minus 3 times 4 plus 2 plus 10 minus 2 times D2 plus 3 equals 0. So 7 minus 3 is 4 times 6 plus 8 times D2 plus 3 equals 0. 24 plus 8D2 plus 24 equals 0. Ran out of space. So I'm going to do 8D2 equals negative 48. Divide both sides by 8, and I have D2 equals negative 6. I finally finished. It's not that hard. I just showed every single step possible, right? All right. All right, recall the opening exercise of lesson 4. Do you remember lesson 4? It was a while ago. Actually, it was just yesterday, wasn't it? That's where we talked about the robot and the beacon. It was 2 lessons ago. So traveling along a linear path right here, y equals 3x minus 600. The robot hears a ping from a homing beacon when it reaches the point 400, 600, and it turns and travels along a linear path given by that perpendicular equation, right? Right there. If the homing beacon lies on the x-axis, what is its exact location? Use your own graph paper to visualize the scenario. I copied it into your notes for you. So if point E is the y-intercept of the original equation, what are the coordinates of point E? That one's easy. The y-intercept is negative 600, and your x value at the y-intercept is always 0. So we've got that one, and we'll label it E. E is 0, negative 600. What are the endpoints of the original segment of motion? So we're going from E to F. So I've got E is 0, negative 600, and F is 400, 600. Endpoints of the original segment. If the beacon lies on the x-axis, what is the y value of this point G? This one takes a little bit of work, right? Oh no, it doesn't. If we're lying on the x-axis, we're going, oh no, we're going over, what is the y value? Yes, the y value is in fact 0 because it's on the x-axis. Sorry, I got myself turned around. And it's right there, the y value. But, so translate the point F, which is 400, 600, to the origin. So I'm doing a minus 400 and a minus 600. What are the coordinates? The coordinates of E prime. I'm going to take my value of E, which I have written on a slide. 0 minus 400. My value of, I'm sorry, it's negative 600 minus 600. F prime is 0, 0, and G prime, which is G minus 400 and negative 600. So cool, make sure you have those written down because I'm moving on to the next question and you won't see the slide anymore, okay? So use the formula derived in this lesson to determine the coordinates of G. So these are going to be perpendicular lines, so I can use that formula to solve for G, okay? So we're going to make sure, we know that EF is perpendicular to FG. So we're going to do EF, so negative 400 times G minus 400 plus F negative 1200, let's get in my bearings, times negative 600. So big numbers, equals 0. So solve this, do some handy math. So I have negative, we're just going to leave this one as is. I'm trying to make this math easier on us because the numbers are getting pretty big. Equals 1200 times 600 is a lot of zeros. 72000, and that would be negative. Divide both sides by negative 400. And I get G minus 400 equals positive 1800. Add 400. 2200 is G. Cool. So if G is G comma 0, we now know that G is 2200, 0. That's the coordinates of G. That was fun. All right, next one. A triangle in the coordinate plane has given vertices. Is a right triangle? If so, at which vertex is the right angle? Hint, plot the points and draw the triangle on a coordinate plane to help you determine which vertex is the best candidate for the right angle. I'm going to see which one's the biggest. So I've got 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. This looks pretty big. 1, 2, 3, 1, 2, 3, 4, 5. I think AB is the possible right angle. sorry, AB is the hypotenuse, with angle C being the possible right angle. So let's map C to the origin. So I'm going to do a +3 and a -5 to everything. So A is going to be +3, -5. B is +3, -5. And that's B prime. And then C prime is going to be 0, 0. So let's see if BC is perpendicular to AC. So we're going to do 3 times -5 plus 5 times 3 equals 0. It's a true statement. It is. We got it. And the right angle is angle C. Good job. All right, last practice problem. So A, B, C, and D are the vertices of a quadrilateral. If AC bisects BD, but BD does not bisect AC, determine whether ABCD is a kite. So AC, I'm not plotting it, but I'm just going to say AC bisects BD, but BD does not bisect. That's not long enough. So those are congruent, but those are not. Okay, is it a kite? So we want to figure out if AC is perpendicular to BD. Okay. All right, I'm going to translate this so that angle A is on the origin. So I am adding 7 and subtracting 1. So C prime is going to be adding 7, subtracting 1. Okay. Then I'm also going to translate BD so that B is on the origin. And that's going to be a +1 and a -3. So D prime is going to be a +1 and a -3. All right, so let's check. I'm going to multiply those and those. 12 times -4 plus -6 times -8. Does that equal 0? This would be -48. +48 does in fact equal 0. Therefore, it's a kite. Awesome. All right, I just threw this on there as a reminder. When we're at the origin, I just multiply it straight out. But if I'm not at the origin, I can get my points to the origin and still save myself a lot of work because we love the distance formula, don't we? All right, have a good one.